Okay, great. So we're here to talk about patient simulation, and specifically because the use of patient simulation can really expand what you can do in a model. Um, so what we're going to do is we're going to introduce patient history into the model by first identifying an event that's important, that has impacts, then using a tracker to record that event as having happened, and then we'll add elements into the model that take advantage of that tracker. So we'll know which patients this event has happened and which other patients it hasn't happened for, and then we can start to have the values used for those different groups of patients differently depending on whether the event has happened or not. So that's what we're going to do over the next approximately half an hour. In order to demonstrate this technique, we're going to use this um, pretty simple training model. It's just a simple decision tree with two strategies, and the strategy they both use the same strategy. This is just a clone of the first one, and it's a four-state Markov with stage 1, stage 2, remission, and dead. There is a probability of relapse after remission, in which case you come back to here and you may progress again. Of course, you could die at any time. And what we're going to focus on is the remission event when we get there. So this is just a standard model, nothing particularly special about this Markov model yet, and we'll start to add the elements now. So two differences between the strategy: the cost in stage 1 up here, and the progression rate probability. So the difference between the strategies is in treatment 2, it costs a little bit more here for treatment, and it's slowing this progression. So treatment 2 will have higher costs here and a slower progression here. So we should expect treatment 2 to be more costly and more effective than treatment 1. But that's just background material before we get into the meat of what we're doing. And now we'll do that. So we want to capture, in this specific example, we want to capture the impact of the relapse. So what we have to imagine is we're building a real model with real progression and a real study as opposed to a training one. And what we've determined from our study of the data is that individuals who've relapsed have different progression here. Like the progression is different, and there's different probabilities of death. So people who have not experienced a remission will have certain values up here in terms of progression and death, and people who have experienced a remission or more than one remission will have different values here. And if we didn't use patient simulation, in essence, in our example, we're going to have a difference between no progressions, one progressions, or two or more progressions. So we really have kind of three different possibilities: no progressions, one progressions, or more than one progression. If we didn't use patient simulation, we would literally have to have 3 cancer 1 states, 3 cancer 2 states, and 3 remission states in order to track the different status of patients in the model. So what you end up, if you try to avoid using patient simulation, you end up with a much more complicated model that has a lot of different states, because anytime anything changes, I need a second one of these states just because this probability changed. Or maybe I need a third one of these states because this probability could change based on multiple events. And you really don't want your model to start to expand in structure. That's really unnecessary. That the only things that really change, let's say in this case, is the progression probability. I can just make this progression probability dependent on whether the event has occurred at a patient level. So making the jump to use patient simulation models can actually make your models a lot simpler and easier to follow than if you start to expand structure into 10, 15, 20, 30 health states, because every time something changes, you need a new way to know whether that person's in cancer stage 1 after 0 progressions, 1 or 2 or more progressions. And microsimulation is just a better way to handle that situation. So that's what we're going to do. And by running patients through, we have the ability to bring patient data along with us. So as person 1 comes through, we know whether patient 1 has had any relapses or not. And that doesn't affect patient 2 or patient 3 or patient 4. So anytime a patient is at any node anywhere in the model, we can record events that occurred along that person's patient history and use that to power the model, to change values in the model. in a similar way that events that occur in real patients affect their future development. And that's ignoring those factors is potentially ending up with a model that's not very accurate. So what we're going to do is we're going to first identify the event. That event is remission. And then the second step is to record it. So we need to know how many remissions have occurred, because the progression and one of the death probabilities are going to change based on the number of relapses. So I have to go to, relapses right here. So here, I picked this one, but I meant this one. So here's where the relapse occurs. This is what I want to record. So it's very simple. I just right click on that node. I define a tracker. I don't have any trackers yet, the tracker to track patient history, so I have a new one. And I'm just going to call it T relapses. And I'm choosing to use a plural here, that S, because I want it to be a count as opposed to yes or no if I had a relapse. So that's just my own little internal mechanism for saying this is a count by putting a plural on the end. And when patients enter the model, I want the value to be 0. I don't want them to already have had relapses as they enter the model. So right now I'm just creating the tracker to track events, and I'm saying when patients enter the model, they haven't had any yet. Now it's saying, okay, at this node, relapse to cancer, what do you want it to be set it equal to? And what I want to set it equal to is itself plus 1. So every time you have one, it will increment this relapse from 0 to 1. If it happens again, 1 to 2, etc. And that's all it took to record this event. Just go to the node, say I want a tracker, and set it to itself plus 1. Or if I only needed to know whether it happened or not, I would just set it to 1. But in this case, I wanted to know the count. So now I have the tracker. It was that easy to just say, this is an event I want to track. And it's totally okay to record events in your simulation model that have no impact at all. You just want to be able to report them. This would be fine if all I want to do was report the number of relapses of my patients. But in this case, I want to do more than that. I want this number of relapses to actually have impacts on the model. That's my second step. Now, before I continue, I'm just going to check for questions. No questions. Okay. So I'll continue. And my impact, there's going to be two. One is going to be a 20% increase in the progression probability after relapse. And in this case, it doesn't matter if it's 1 relapse or 2 relapses. So this progression is going to be 20% higher after a relapse. So how do I do that? Well, I'm going to have to go to where my probability of relapse is defined, or excuse me, probability of progression is defined, and it's actually not defined way back here because it changes by strategy. So I have to make the adjustment to the progression probability here and here so that I add 20% to that probability, which is different for the two strategies. So I'm going to come to this node. I'm going to right click on it. I'm going to define a variable, pprogress. And this was a little bit, I expected it to just be without this, so I'm going to just take that out because it should have been that already. And what I want it to be is if my tracker relapses is equal to 0, then it's just my baseline probability that I had before. Notice when I'm in a function, it tells me how the function works in case I don't know what the syntax is. So if I haven't had a relapse, then it's just the standard one that it was before. Although I had a little mistake in there. It should have just said progress to SOC before. But if it has happened, if I have had a relapse, then it's going to be equal to that same variable, standard of care, progression, but I need to multiply that times the 20% adjustment, which I already have in the model as an adjustment from relapse. This is a 20%. Okay, and I actually have that wrong. I need it to be 1 plus that, right? Because if this is 20%, then I need it to be whatever the original value was before for no relapses, and then that value adjusted up by 20% if I have had the progression. So that 1 is just the baseline plus another 20%. So if this is 10%, this will be 12%. And it will know when the patient comes through and experiences that progression risk. If they had a relapse, it'll be 20% higher than if I haven't. And I can click OK. And I need to do the same thing down here. Define variable, P progress. This was a mistake. And I need to change it to say if my tracker T relapses is equal to 0, then it's its original value. Otherwise, it's the original value, which was the new treatment progression probability. I see a question, I'll get to it in a second, multiplied by 1 plus the adjustment. I need to close the parentheses on this 1 plus, and then I need to close the parentheses on the if, and now I have my thing built in. I saw a question, so I'll take that now. So the question is from Louise. Does the initial if statement imply that if relapses is greater than 1, the model? Yes, that is true. So if I look at either one of these again, the if works just like in Excel. This is your condition. Is this true? If it is true, it just uses this, and the semicolons break it up. If this is not true, meaning if it's 1 or 2 or 3 or whatever it is, it's going to use this expression because it won't be 0. So that's how the if works. And that's why I didn't say if tree relapses equal 1 this way, because then if it were 2, it would get messed up. By just saying 0, I know this is no progressions, and this is any number of progressions that's greater than 0, and it'll be fine. Okay, so there's my probability of the regression. And then I also had one more impact, and that has to do with the probability of the relapse. So your probability of relapse also, I said death before, I was wrong. It's the probability of relapse that's going to change. And I already created a table in this model here to represent the change in probabilities from 10% to 12% to 15% based on the number of relapses. The way tables work with interpolation, it will continue to use this value if I get to 3, 4, 5, 6, 7. I don't have to have those. It'll just continue to do this too. So I don't need to worry about beyond that. Now I could change it so that it wouldn't actually allow me to extend off the edge, but I have the table set up so that it will. And so in order to incorporate this changing twice value, I have to come back to my p-relapse, and it's not just 12% anymore. I need to change that probability. Here's a filter. If I type a P, R, it only shows me the variables that start with PR. And instead of being 12%, I'm just going to delete that, and I'm going to pull the data out of a table. So this is the value, the calculation for p-relapse comes from this table, and where I'm going to pull it out of the table is based on the tracker. So when the tracker is 0, it's going to return 10%. When it's 1, it'll return 12%. If it's 2 or anything higher, it'll return 15%. So I've done everything I need to do to the model to make it work. Now I'm going to assume I made a small syntax error somewhere, and I'm just going to skip to this model, which already has all that stuff in, just in case I made any mistakes. I won't delay you with trying to figure out what I did wrong. And I'm going to start from here. And I'm going to run the model from here. And a couple of things that I've done in this model, I'm also tracking patient history in this model, and I'm also tracking some calculations. But it's all in place, but I cannot and should not go directly to the rankings anymore. And the software will warn you, this model contains trackers or patient level distributions. It should be analyzed via microsimulation. The analysis that you're running is probably not appropriate. Do you want to run it? No, I don't. It's just a warning to not run inappropriate analyses. But what I should and can run is this microsimulation, individual patients. And I'll go ahead and let those 10,000 patients go, and I'll check the questions while we're going. Yes, all the questions are answered. And now I have run my patients through, and it's just collecting all the data. It's taking a little longer than it would because I have the patient tracking on, which we'll look at in a little while. And now I get my results. And this is a database of all the 10,000 patients. Right, here's my 10,000 patients. This is the mean cost for each of the two strategies, my mean qualities for each of the two strategies. And from these results, which included the impact of relapses, now I can get my cost effectiveness rankings to evaluate my optimal strategy. So here's the means from the simulation for the two strategies. So my expected value for cost for each strategy, incremental cost, for qualities for each strategy, incremental effectiveness or qualities, and here's my ICER 20,000. So through therapy would be preferred if we assume a $50,000 willingness to pay. So what I've done so far is I integrated the impact of the relapse, and the impact of the relapse was first I recorded it, and then it impacted here at this probability as well as the progression probability. And what I'm trying to emphasize is when you're studying the disease and building a realistic model, if there are important events, you shouldn't ignore them. If those events actually impact downstream values, affect the way the disease progresses, and you ignore them because you don't feel like doing a simulation model, you're making a mistake, and you're coming out with not invalid so much as less than ideally accurate results. So, and you saw how easy it was. It's just a simple, you don't have to start over. All I did was record the event and integrate that event into this probability and this probability, and that took 10 minutes max. Now, I've done it many times, so maybe it'll take a little bit longer, but it's not an overwhelming burden to integrate that in the model and get yourself more accurate results. So a couple of things I wanted to look at in addition, in terms of validating what we've done, is I want to look at patient history. I want to look at at patient tracking reports. Now, what I didn't show you in this model is in tree preferences, I have a couple of things set. One is this time reporting. And what this basically says is I want to record every movement of every patient at every node in every cycle in the model. And not only do I want to see where they went, I want to see how that affected cost, how that affected qualities, and how that affected the tracker. So that data was collected, and now I can report on it. The other thing that I set in the tree preferences, well, there's two more things I want to show. One is I have seeding on, which means I can run this as many times as I want. I'll always get the same results. So that was just so that I knew where to look to show you different things. And then the third thing I want to show you is I have debugging set specifically to output like only one trial and only specific calculations that I want. So we can actually look at the impact of the more complicated calculations that I put in the model. Now, why I chose trial number 9,410, I'm not sure, but that's what I did. So that was all in place. And now if I look back at the original output and the outputs, the additional options over here, and I go to time report, and I'll just choose the first strategy. I could do it on either. I can see what happened to the patients. So here's my first patient. Immediately progressed, survived, and then died. Here's my second patient. Entered remission. Here's a relapse. I know with the relapse, it should have updated the tracker. Did it? Yes, it did. And now I'm back to cancer 1. They finally progressed to cancer 2 and finally died. And I can do this for any patient out of the 10,000, including my 9410. I don't know why I picked that one. Probably because the person had a lot of remissions and relapses. And so it was an interesting person. If I scroll down, yep. I picked that specific person because that person had a lot of relapses, and because of the multiple relapses, I can check the different conditions that I set in the model to make sure that they were applied correctly. So that's why I specifically wanted to look at this person 9410. So that's kind of an interesting thing. I can take my results, I can look at the all data report, and I can look at the relapses and stuff and say, you know what? I'm really interested in this guy because he had 2 relapses. What I found was if I look at 9410, that person had a lot of relapses. So that's an interesting patient to follow. Okay, so you can see the individuals coming through here, and we'll focus on 9410 in a little while, but I can also generate the cohort level details. And this is something that until maybe a year and a half ago, you could only get this output from cohort models. But when we built in the patient tracking, we were also able to build in this cohort level reporting. So when we look at this and we see this first progression, right? This isn't percentages applied to a cohort of one. This is out of the 10,000 patients, 150 of them died. 1,040 of them approximately progressed. 940 of them entered remission, and most of them stayed here. So all these percentages were regenerated from the individual 10,000 patients, and I can see the whole flow of my cohort, including graphically, of what happened to the patients. Now, in a cohort model, everything would be very smooth because it's all based on percentages, so everything comes out really smooth. In this report, there may be a little bit more kind of jaggedness because you're talking about patients. It's not all aggregated out into nice clean fractions. So because I ran enough patients, they're still smooth. But if I only ran, let's say, 100 patients, it would look a little jagged. But here's my overall progression: death going up, cancer stage 1 going down, and remission kind of rising. So by the end of the 25 years, I have a lot of people dead, but quite a few people in remission. So that's the patient tracking report that came out of the simulation. And then the last thing I wanted to look at was the specific elements that I asked to look at for debugging. So if we go back to the model for a second, and you remember I set it up to look at patient 9410, but I really selected it to look at just this calculation, the probability of relapse, and the variable definitions that are here, this one, p-progress, and also here, p-progress. So those were the only ones that were dependent on the relapses. Those were the only ones I was worried about. Those are the only ones I wanted to track. Because if I look out here in the console, if you just record everything, then this gets overloaded with so much data that it slows down your analysis to the point of it may not run. So here's my 9.4. It should start because I asked for 9.410. Here's my trial 9.410. And here's the probability of progression if I've had 0 relapses, and it's 10%. Good. That's what I wanted. Now I'm kind of interested if I go down to wait till they've had a relapse, still no relapses. Finally, here in stage 4, we've had a relapse, right? So there's been a relapse, and now my probability for progression is 12%. So I've used this debugging output to validate that when the person had 0 relapses, it was 10%, and when the person had 1 relapse, it was 12%. So I validated that the not super complicated, but the mildly complicated event or probability calculation of my model is working the way I expected it to. And if I looked at treatment 2, it would be just slightly different. Now, I also wanted to see about my probability of relapse, which should go from 10% to 12% to 15% based on the number of relapse. So I can look at that person, and I've already recorded where to look. But here in stage 3, the probability of relapse with no prior relapses was 10%. That's what I wanted it to be. Now, if I skip forward to stage 6, here's stage 6. Now the person had 1 relapse, and now the probability of relapse has changed to 12%. And if I skip even further to stage 16, I already wrote down where to look, so I didn't have to keep kind of searching for it. Now the person's experienced the same risk of relapse, but they've had 2 prior relapses, and that probability is up to 15%. And I just want to make sure it didn't change again because it should stay 15% after that. So if I go down to stage 19, now the person has had 3 relapses, and the probability remains 15%. So that's what I wanted to make sure was working, and that's really all I had to show you today, but I want to kind of do a little summary of what happened. So imagine this in your own model. What we had was we had a disease, we had a Markov model that represented it, and we determined that relapse had long-standing impact. both in the probability of relapse and the probability of progression. So what did we do? The first thing we do is record the number of relapses, and then we integrated the number of relapses into the probabilities for progression and relapse here and here for progression and back here for relapse, because that doesn't change by strategy. And then we looked at patient tracking reports so we could see where the patients have gone, individual patients and cohort level of all the patients. And finally, we looked at specific calculations that were affected by that tracker to make sure they were doing what we had designed the model to do. And that's really all I had to show you today. So I'll just open it up for questions before we conclude. Does anyone have any questions for me? Okay, I'll wait another minute to see if anyone has any more questions. And if not, oh, here we got a question. Can you use trackers in the decision tree? Yes, you absolutely can use trackers in decision tree. There's not really much of a reason to most of the time. For example, because I'm just going to open up a model. If you have, this is a very simple decision tree. So imagine that these patient pathways went a little further. If you're here, you know everything that happened along that way because there's no repetition to it. There's no next cycle. So you don't really need a tracker, because if you were going to record something here, you'd know what happened here anyway. So there's much less need for trackers in a decision tree, but you absolutely can use them. Another question came in from Artem about can I use trackers in a DES model? Not only can you absolutely should, because there's probably going to be events that are really important in a DES model. But absolutely, if you open up a DES model, there's in the files view, here in discrete event simulation, this osteo DES model has a lot of trackers. It has it's a kind of a complicated model. Shouldn't be the first one you look at, but I've got all these trackers involved, and they're all set at different places in the model. So it's very highly likely that you would use trackers in a decision tree. Now, Louise, where trackers would help it make less busy, I don't think it really would help make it less busy. I think you're going to end up with as many nodes as you need for the patient pathways, and there's not a lot trackers can do to break it down. Where it becomes useful is in a Markov model where you're returning to the same places all the time. So in a Markov model, you keep coming back to these same nodes, and what trackers do is say, okay, I'm at this node. I know what's happened in the past because I may hit this node 8-9 times, or this node 6 or 7 times, and you probably need to know what's happened in the past, or you may need to know what's happened in the past to see how it affects cost, utilities, the progressions. Think about a stroke, for example. Stroke would be could be a semi-catastrophic adverse event. It would likely mean that you have higher costs into the future. It would likely mean you have lower utilities in the future, and it probably increases some risks, maybe for future strokes. So that would be an example where it kind of affects 3 different sets of values in the model. And because in the Markov structure you keep coming back to the same nodes, you need to know whether that stroke has occurred. Like, for example, when you're here, you're coming back to here whether you'd had a relapse or not. And this probability is going to be calculated whether you've had the relapse or not. But by recording it here, I was able to change the progression probability here and here to experience that risk differently, even though you're at the same node. Whereas in a decision model, you don't really come back to those nodes, so it doesn't really help. It doesn't have as much of a purpose. Any other questions before we conclude? Okay, well, thank you very much for joining me today. I really appreciate your time, and we will post this up to our website, either this or a different recording of the same demo. So if you or anyone else wants to see it in the future, it'll be there. Thank you very much, and have a great day.